This is Nest, the habitat for some of the open source packages and repositories that help in analyzing clinical trials data. But now we will focus on one of these birds called Teal. Teal is a Shiny based interactive exploration framework for analyzing data, with particular emphasis on CDIS clinical trial data. With the help of Teal, you can build a feature rich Shiny app like this with just a few lines of code. Let's break down the 5 key components of a Shiny app created using Teal. The application header is a custom title for your app. The Teal modules are the tabs which encapsulate an analysis that can be done in the app. The encoding panel is a module specific UI for a given analysis used for customization of the output. The main output panel is where the outputs for a given module will be displayed. The filter panel can be used to filter the datasets before running a particular analysis on them. Additionally, we have two more components as part of the Teal framework, reporting and reproducibility. If the Teal module that you use supports reporting, you will see the reporter options that allow you to add your analysis to a report, download the report, and reset the report. If any of your Teal module in your app supports reporting, you will get an additional Teal module tab called Report Previewer, which can be used to preview and modify the contents of your report. If the Teal module that you use supports code reproducibility, you will see a Show R code button, which will display the R code needed to reproduce the output of your analysis. At a high level, the application header, filter panel, and Teal module tabs are created by Teal, while the encoding panel, main output panel are created by Teal module packages. We can group the people who interact with the Teal framework into three broad groups. Teal User is someone who uses the Teal app for exploratory data analysis. App Developer is a person who creates the Teal apps which are consumed by Teal users. Sometimes the app developer might also be the user. Module developer is a person who creates custom Teal modules to satisfy their needs. Typically, if a study requires some analysis that does not have a module available, Teal module developers would help in creating it. Let's talk about using the Teal framework from each of these perspectives. A Teal user will be able to do these actions while using a Teal app. Selecting the Teal module from the available module tabs, filtering the app data from the filter panel, customizing the output using the encoding panel of a specific module and having a look at the output, using the Show R code button to get the code to reproduce the displayed output, adding the output to the report, if needed, navigating to the report previewer to customize and download the report. A Teal app developer's main responsibility is to build the app. And you might wonder, it must be challenging to build a feature-rich Shiny app like this. But that's not the case. The encoding panel and the main output panel come from the Teal module packages, while the filter panel is automatically built by Teal. So what does a Teal app developer do? Data. The main responsibility of the Teal app developer is to provide the data into the Teal app and of course choosing the right modules for analysis. Currently, Teal apps accepts data frame, CDISC format data frame, multi-assay experiment objects as input. It is also possible to pass data from a remote database into Teal apps. Now let's see how we can build a Teal app. We start by calling the library Teal. Note that this also attaches the Teal helper packages, Teal code, Teal data, and Teal slice in your R session. Now we call the init function from Teal, which takes two required arguments, data and modules. Once we provide valid data and modules into init, it will return a list of Shiny UI and server objects, which can be passed into the Shiny app function to create our desired Teal app. If you choose to add a custom title for the browser tab, you can do so using the title argument of init. We can also add a favicon image to the title, which can be a remote or a local path for the image. There is a convenient function that helps in creating the HTML tags to do this. The header argument can be used to add custom UI at the top of the Teal app, while the footer argument can be used to add custom UI at the bottom of the Teal app. Let's get back to the simple Teal app with just the data and modules specified, and bring the data and modules creation outside the init function so it becomes clear what we're about to do. Let's add a new data to the app. You'll notice that the filter panel gets updated with this new data, and all we had to do was provide this data. Now let's try adding a new module to the app. This should create a new module tab in our app. Abstraction does not get any simpler than this. Now let's dive deeper into the creation of data and modules respectively. When it comes to creating the data, you need to consider if your data depends on some custom UI during the app initialization. You can use the Teal data function if the data for your app is common across all the Teal users. Alternatively, with the help of the Teal data module function, you can create custom UI before the data creation, which can be helpful if you want to set up a UI based authentication to fetch the data or pre-processing it before Teal data is created. It is possible to provide all the supported data formats using either of these functions. When it comes to modules, you can use the modules from a growing repository of Teal modules provided in these packages. Teal modules general for general modules to explore data, Teal modules clinical for modules specific to CDISC data, Teal modules Hermes for modules that analyze multi-assay experiment objects. We recommend going through the TLG catalog and biomarker catalog, which showcases the use of the modules from these packages in practical scenarios. Calling the Teal data function creates an S4 class object with the same name Teal data. This class helps to achieve reproducibility of the code, ability to pass the datasets to the required modules, and create and manage the filter panel. These are the key slots of Teal data that help with this. Env is the isolated environment that stores and manipulates the data. Data names contain the names of the data objects so that they can be used by the modules and the filter panel. Code slot contains the R code that is used to create this data. Reproducibility starts with data creation. The verified slot is a logical value that indicates whether the code produces the same datasets present inside the env. Join keys is an object of class join keys, which is used to establish relations between different datasets. This is optional and only helpful when working with CDISC or SDTM datasets. Let's put a pin on this till we get to the CDISC data creation. These are all the methods available for the Teal data object. Data names can be used to get and set the data names slot. GetCode method will get the code from the code slot. The verify method can be used to run the verification check, which runs the code from the code slot and compares the generated datasets with the datasets available in the env. The within function can be used to evaluate the code directly in the env slot. Now let's see how we can practically use these methods to create a valid Teal data object. The Teal data function can take named arguments of data objects that we want to create. In this case, we are creating a Teal data object with a single data object empty cars with just the first 6 rows of empty cars. If we try to get the code for this Teal data object using the getCode method, you'll realize that we just have a warning and nothing else. This is because the Teal data object is not reproducible yet. To make it reproducible, we need to pass the code that was used to create this data in the code argument of the Teal data function. Once we do this, you'll see that the code is returned, but the warning still remains. This warning is because Technically, we are free to pass any string as code to create this data. However, this code string might not produce the same data. This can also be realized once we print this data. It should say that it is an unverified Teal data object. To fix this, we just have to run the verify method on the Teal data object. This will run the code and compare the generated data with the data available in the env. The verify method will return the verified Teal data object if the check is successful. Otherwise, it will raise an error. So we still have to reassign the result of the verify method to the data object. Since verify takes and returns a Teal data object, it can be chained using the pipe operator. But this is just one of the workflows to create Teal data. As you can see, we are specifying the code twice. So this workflow is generally useful if you're not interested in code reproducibility. The recommended workflow, if you are interested in code reproducibility, is with the use of the within function. Let's create an empty Teal data object. It is still verified since the code is empty and so is the environment. The within method has two required arguments, a Teal data object and the code as an expression. This code will be evaluated in the environment of the Teal data object. If we print the data, you'll see that it's verified. This is because the code expression passed to the within function is appended to the code slot while also updating the environment slot. So a verified Teal data object will stay verified if within is used to update it. Since objects in your current environment are not available inside within's environment, you can pass additional arguments so within can access them. Sometimes this is helpful. For example, when you are experimenting with some objects from your environment to create a Teal data object. In our previous workflow, we can always access the variables declared in our current environment. However, since they cannot be accessed inside the Teal data's environment, always keep in mind that your code string should always be able to recreate the data when run independently. We can get the code using the getCode in both workflows. Note that the rows was replaced by its value in the within workflow. If we try to get the data names, you'll realize that it is empty in the case of the within workflow. If the data names is empty, Teal will try to pass all the valid datasets in the environment as datasets in the Teal app. But it is recommended that data names is provided explicitly. It can be done by assigning a vector of names to the function call. Now the Teal data objects from both the workflows are identical. Since the within method returns a Teal data object, we can chain it using the pipe operator similar to the verify method. So far, we've seen how to pass an R data frame into Teal data. Passing a multi-assay experiment object is just like this. All you need to do is pass the multi-assay experiment object instead of a data frame. Note that all modules are not compatible with this data format, so you'll have to use the modules that are compatible with MAE. Let's talk about CDisk datasets. CDisk datasets are standardized data frames. They are also relational datasets, making them easy to join with other CDisk datasets. They can also have parent-child relationships between them. For example, when the ADSL is filtered, all the child datasets are filtered based on this. With the help of join keys, it is possible to work with CDisk datasets as well as custom SDTM standards. We saw that the join keys slot of the Teal data object takes an object of join keys class. Now let's dive deep into it. Calling the join keys function creates an S3 class object with the same name join keys. This class helps to achieve filtering datasets with parent-child mapping in the filter panel, merging relational datasets using foreign keys in a specific module when required. The join keys object stores multiple key relationships, each of which contains information about one join relationship created using the join key function. The join key function has four arguments. Dataset 1 and dataset 2 are names of the datasets for the join mapping. Keys is a character vector of the column names used for the join mapping. Directed is true by default and tells if dataset 1 is the parent of dataset 2 or not. You can create one of these three types of key mappings using the join key function. If dataset 1 and dataset 2 are the same, it means that the keys are the primary keys of this dataset. In this case, the primary key of df1 is id. When dataset 1 and dataset 2 are different, the keys represent the foreign key to join them. Since directed is true by default, it also means that df1 is the parent of df2. When directed is set to false, it implies that df2 is not the parent of df3. Now you can simply pass your required keys inside the join keys function to create the join keys object. You can print the join keys to see the join mapping it represents. The join keys can be subsetted using the square bracket when a vector of dataset names is passed into it. If you wish to see the join key columns between two specific datasets, you can pass both dataset names inside the square bracket separated by a comma. Note that you can modify their join columns by assigning a new set of columns. You can view the parents of the join keys object using the parents method. Since it returns a list, you can subset parents of particular datasets. Note that you can also modify the parents by assigning new values to them. Teal exports the default cdisk join keys object, which contains the default join key mappings for the standard cdisk datasets. It's noteworthy that you can use C function to combine multiple join keys mappings together. Now that we know how to use join keys, let's see how to create a Teal data object with cdisk datasets. Here we are trying to create a Teal data object with ADSL and ADAE datasets. When we print the Teal data, everything looks okay. The only caveat right now is that these datasets would be considered as normal data frame in Teal. When we get the join keys of this Teal data object using the join keys method, we get an empty join keys object. So we have to set the join keys. We do this by subsetting the default cdisk join keys for the data names that we want. Now the join keys returns the proper keys for both our datasets. And that's all the change we wanted to do to use cdisk datasets in Teal. In case of working with custom SDTM standards, you just need to make sure that you provide the proper join keys according to its standards. This wraps up the creation of data using Teal data function. Let's see why there are cases where Teal data function is not enough to create and pass data into Teal apps and we need an additional function called Teal data module. Imagine a scenario where your Teal app requires user-based authentication before the study data can be pulled or processed. In this case, you might want to set up a user login page before the Teal app is loaded. There could also be a scenario where you would like to pre-process the data before your Teal app is generated, like the ability to select from a list of different study data. These problems are solved by giving the developer the ability to create a custom Shiny module which can be passed into the data argument of the Teal init function. You just need to create module UI with custom user interface to satisfy your needs and a module server that returns a reactive Teal data which is then passed into the Teal app. These module UI and server functions need to be passed into the Teal data module functions UI and server parameters respectively. Once this is done, before the Teal app is initiated, this custom Shiny module will be shown and the Teal data which is returned from the server will be used to initialize the Teal app. Let's see how to achieve this practically. In this example, we just have an action button in the module UI and in the module server, we return our usual Teal data when the action button is clicked. When we run this app, instead of the usual Teal app page, we now see the UI that we created right now, which is just a submit button. Once we click this button, the Teal app is loaded with the Teal data that was returned by the server. Let's modify the Teal data module and add numeric input to select the number of rows of empty cars. In the module server, we pass this input as a parameter inside the within function and use it to subset the first n rows. Now when we load the app, we see that the UI has numeric input and a submit button. When we click the submit button this time, we can see that the Teal app is loaded with the end rows that was selected before initialization. This wraps up how we can create and pass data into Teal app. When it comes to modules, you can use the modules from the Teal packages. All the module functions start with the prefix tm. You can also add multiple of these modules together with the help of the modules function. They can also be nested inside each other. Let's dive into creating custom module as a module developer. Before that, let's see how Shiny modules are created. Shiny modules allow us to create reusable UI and server logic using our functions. Here's an example of a simple Shiny module. To create a Shiny app using this module, we just have to call these functions in the UI and server respectively. When we run this Shiny app, we get a simple Shiny app with an action button that shows a notification when clicked. A Teal module can be created by simply passing this module's UI and server functions into the UI and server arguments of the module function from Teal. To make this easy to use, we return this from a function. Let's see how an app developer would use this module. They create a Teal data as usual. Inside the init function, they pass this data and call our custom Teal module in the module's argument. When this app is run, we can see that it creates the exact same Shiny app with some custom Teal components like the module tab. Now let's gradually add more features to this module. We can add a custom label to this module using the label argument. It's a good idea to allow the app developer to edit this title. So we can get this label from an argument to our custom module function. One of the key features of Teal module is to take the data passed into the app and automatically provide a filter panel to filter this data. To opt into this feature, all we need to do is pass a data argument to the module server function. Teal will automatically create a filter panel and provide the server function with a reactive Teal data object, which is a result of the Teal data passed by the app developer filtered by the filter panel. Now let's make use of this data and display the rows of iris dataset by creating a text output in the UI function and rendering the number of rows of iris in the server function. The data names argument can be used to subset which datasets need to be passed into the module server function. By default, it is set to all, which gives the module access to all the datasets passed into the app. Let's make it iris, so this module only has access to the iris dataset. When we do this, the filter panel will only show the iris dataset, and the server function can only access the iris dataset. Let's add the custom title inside our module. If we want to set this title from outside the UI function, we can achieve this by passing custom arguments to the module UI function by passing them as a named list in the UI args argument of the module. If we want to give the app developer the ability to influence the UI args, we can get this value from the Teal module function as well. The same can be done for the server function by passing the server args in the module. Now the app developer can directly influence server logic as well. Let's quickly summarize what we have seen so far. Teal modules can be created using the module function of Teal. The Shiny module UI and server functions are arguments of the module function. Passing a data argument to the server function gains access to the filtered Teal data inside the server. Custom arguments can be passed into the UI and server functions using the UI args and server args respectively. Let's go back to the simple Teal app example and restructure the Teal module so we have some space. We do this by bringing the module UI and server functions to the right side.
Most of the Teal modules use the verbatim pop-up module from the Teal widgets package to show reproducible code. To use this, we have to call the verbatim pop-up UI, which creates a show our code button in our module. We also have to call the verbatim pop-up server in our server code, which takes three arguments: ID, verbatim content, and title. The ID takes the module ID to connect the verbatim pop-up UI and server. The verbatim content takes our code to be shown in the pop-up, and the title takes the title for the pop-up. When we click the Show R code button, we can see a pop-up with the title and the R code that we passed. Of course, this R code is not the correct R code to reproduce our output, and we can manually provide the R code that is needed to reproduce our text output. But there are two problems with this approach. First, the R code is hard coded, so when we make changes to our analysis, we need to make sure the change is made to the reproducible code as well, which makes it hard to maintain. Second, this is still not a complete R code to reproduce the output because we have not included the data creation code for iris. To solve this, we want to create the output in a way that is reproducible. We can do this with the help of the Teal data by creating a new Teal data object with our analysis. Now we can use the getCode function from the Teal code package to get the complete code to reproduce this analysis. Now, when we click the Show R code button, we can see that the dynamic code to reproduce the output is present. However, there is still a warning that says code was not verified for reproducibility. This is because ultimately the data reproducibility is in the hands of the app developer. And if the app developer does not provide a Teal data object with the code to generate the data, complete reproducibility is not possible. Let's fix this by passing the Teal data object, which is reproducible. Now, we also get the data creation code in the pop-up to ensure reproducibility. Note that any active filters in the filter panel will also be dynamically added to this code. To summarize, the code contains any identified library calls, the data creation code which is provided by the Teal App Developer, data filter code performed by the filter panel, and code provided by the module. Now let's remove the pop-up module and see how we can create a report using the module content. Let's also replace the text output with a plot before we create the report. In this case, we create a simple scatter plot. To add the reporting feature, we will use the Simple Reporter module from the Teal Widgets package. Adding a simple reporter UI creates the reporter buttons in our module. But to make it work, we need to pass the reporter argument in the server function. This will create a report previewer tab in our Teal app. Now we have to call the simple reporter server function. It takes at least three arguments: ID, reporter, and card function. The ID takes the module ID to connect the simple report UI with the server. The reporter is the reporter object obtained from the server. The card function is a custom function that helps us to create the custom report card for this module. It provides an R6 class object of report card which can be manipulated to create a custom report card. Here are some of the methods of the report card class. We will just use the append plot method to add our plot result to the report. For a more comprehensive understanding of the class, please check the vignettes and documentation from the Teal Reporter package. When we navigate to the Report Previewer tab, we can see that there are no cards. But when a user adds a report card, the Report Previewer tab will show the report card with the plot that we appended. This summarizes how to create a custom Teal module with code reproducibility and reporting feature. It is recommended going through the package vignettes and documentation for a detailed understanding of the Teal features.